Okay, this second video is going to explain equilibrium in terms of looking at the Haber process in particular. So what I've got here is the equation for the Haber process. It shows you that we have hydrogen reacting with nitrogen to make ammonia. I've balanced this equation already, so you see it's going to work for us. And I've also labelled, and you have to be told this information, the forward direction is exothermic, so I've labelled it, and the backward direction of this reaction is endothermic. Remember, in the middle, we've got this reversible arrow. This means the reaction going in the forward direction and the backward direction. And because it's equilibrium, this dynamic equilibrium at the moment is happening at the same rate. So the forward and back reactions are happening at the same rate. Before we get into this, let's just add some labels to this. And I suggest you always do this when you're faced with a question. So exothermic means that energy is going to be released. That's going to cause the surroundings to become hotter. And the opposite is true, where the reaction is endothermic. That's going to cause heat energy to be taken in. That's going to cause the surroundings to become cooler. We're also going to look at the number of moles in the equation. So at the moment, this side, there's 3 moles of hydrogen and 1 mole of nitrogen. So that gives me a total of 4 moles. And on this side, we have 2 moles of ammonia. Okay, and we'll use that later on. So in terms of what we can do to this reaction, we're going to try and make more ammonia. So I need to change conditions that's going to make the equilibrium move in this right-hand direction, the forward direction, towards the ammonia. Okay, so my first condition, if I lower the temperature, then remembering Le Chatelier's principle says that this reaction will do the opposite. So this reaction is going to try and increase the temperature. To do that, the equilibrium is going to move towards the right, because this is where it's going to get hotter, and that's going to cause the increase in temperature. So here, the equilibrium moves to the right, and that's because this reaction is exothermic. Let's give our reason. Because this reaction is exothermic in this direction. What will that do? That's going to lead to an increase in the amount of ammonia. Okay. If you look at the same for pressure, if I was to change the pressure in this reaction, so if I increase the pressure, then LCP says this reaction will do the opposite. This reaction is going to try and lower the pressure. Which way is it going to move to lower the pressure? We'll come back to this information. Here there are 2 moles against 4. 2 moles is going to have a lower pressure, so the equilibrium is going to move to the right. So again, equilibrium moves to the right. Why does it do that? Because there are less moles, give the reason. And what does that do to the amount of ammonia? If it's moving this way, we're going to get an increase in the amount of ammonia. Okay, so the 2 conditions that we want to do, we want to change. 1 is we want to lower the temperature, and 2, we want to increase the pressure. The problem with this is this leads us to a problem. If we get into a situation where we lower the temperature, we have to use our understanding of rates of reaction. Rates of reaction says we lower the temperature, the reaction will become slower, because the particles have less energy, therefore they'll move around less, therefore there'll be less chance of successful collisions, the reaction goes slower. If we increase the pressure, in terms of attainment, that's good, because increasing the pressure means it's going to cause more collisions to happen. But the problem is that this then becomes more expensive, because all these chemicals in this equation are gases. If we increase the pressure of those gases, then we have to reinforce the pipes. So there is an issue here in that we would have to look at pipe reinforcement, or pipes reinforced. Okay, so we have to reinforce pipes in order to make this work. So the reaction wants these conditions. This is why we don't want to do that. When we've got 2 conflicting views, what do we need to do? We need to reach a compromise. Okay, and the compromise conditions for the Haber process balance out these 2 arguments. So for temperature, the temperature that they have identified as being the best compromise is 450 degrees. This, if we go back to this information, is still quite low, but it's high enough to give us a decent rate of reaction. The pressure is 200 atmospheres. Again, This is quite high, so it's 200 times atmospheric pressure that we normally have around us, but it's not high enough that's going to lead to expenses. The other thing we can do to help with all this is we can actually add into this an ion catalyst. Think back again to the work on rates of reaction. Catalysts speed up chemical reactions. They do this by lowering the activation energy. So this is going to lower activation energy. It's also going to speed up the forward and backward reactions by the same amount. So it doesn't change the position of the equilibrium, but it speeds up the attainment. Okay, the attainment of this happens much quicker. So this is set up in a shorter time frame. Okay, the other thing we've got going on, if you remember how this is set up, we have our little reaction chamber in the Haber process, which looks like this, and they have these catalyst beds, and on top of these beds they put the iron on. So there's my iron. They could finely chop this. You should know why it's finely chopped, because it gives a bigger surface area, therefore helping it to have more chance of reactions. The gases come in and the gases have to pass over the surface, therefore encouraging them or giving a greater chance to react. Okay, so hopefully that goes through the Haber process, compromise conditions, and why we have to do that, linking it all to Le Chatelier's principle. And if you're stuck on the basics of that and want a refresher, go back to the video on the basics of Equilibria, and that will help you get into that again.